So this is a nice scenario. The box is 5 kilogram, and Joseph applying 100 Newton. I want you to find the net force. I also want you to find acceleration. I also want you to find draw the force diagram. The second scenario. Well, second and third scenario is kind of only one scenario. Okay, if you go to a shopping mall, what do? You take a shopping cart. You take a shopping cart. Okay, you take a shopping cart. If you take a shopping cart, as soon as you hold the shopping cart will not start moving, right? How many of you think as soon as you hold the shopping cart will start moving? It won't start moving until you apply forces. Even if you apply forces, shopping cart tells you, I'm not gonna moving. Oh, why? Why does it tell you that it doesn't want to move? Because the first part of Newton's first law. The first part of Newton's first law tells us that object at rest like to stay at rest. Let's say this chair is a shopping cart. The shopping cart at rest loves to stay at rest, and it refuses to move. Unless when it moves when you apply Newton's first law, third part. What is the third part of the first law? Unless it experiences some external force. What is external force? This is external force. If you apply some external force, then it starts moving. However, it's very difficult for you to move an object at rest. Why is that? Because you have to overcome the inertia. Static, friction and inertia, both. So let's understand that. So I have a box, 5 kilogram. Applied force is, 100 Newton. This is the very beginning. At the very beginning, when object is at rest. So object at rest. This is when object is already in motion. 100 Newton. This is 5 kilogram. Okay. So before that, we need to understand few things. Now, friction. The coefficient of friction always between 0 to 1. It can never be smaller than 0, and it can never be bigger than 1. And friction there are two types of friction. One is static friction and one is kinetic friction. Static friction when object is at rest. When you have to apply extra force to overcome the inertia. Kinetic friction when object is at motion. Understand the hypothesis. The hypothesis is static friction is always greater than the kinetic friction. This is true. With that tools, we are ready to solve these three scenarios. Let's do it. Let's do the first one. The net force. At y direction, there is no force going on because normal force and gravitational force cancel each other. So the gravitational force Fz is equal to ma. M is 5, a is 9.8, which is 49 Newton. Normal force is 49 Newton. So they cancel each other. However, the x direction, 100 x direction 100 Newton minus 0 Newton. There is nothing, no Tyler is no friction, since we said this is frictionless. No Tyler, no friction, no Joseph. 100 Newton minus 0, so 100 Newton. Acceleration is F over m, 100 over 5, 20 meter per second square. So this box is accelerating 20 meter per second every second. So you're gonna draw the diagram. F sub z, F sub n, 100 Newton, and accelerate 20 meter per second square to the east. Okay, we're done with this one. Now we're gonna do scenario number 2, which is interesting. Scenario number 2, we have to find the same thing. We have to find the net force. Okay. So net force. So this is the static friction. So static friction is the ratio of overcoming force over normal force. If you do cross multiplication, then overcoming force is equal to mu sub s, which is static friction, coefficient of static friction, and normal force. So overcoming force is 0.68, right? Okay, I did not give you friction. So static friction is, let's say, 0.60, and kinetic friction is, say, 0.50. 0 times 49, which would be. So now net force at x direction is 100 Newton minus 29.4, 70.6, and net force is this direction. Net force 70.6 is this direction. Now we're gonna find the acceleration. Acceleration is 70.6 divided by 5 meter per second square, and acceleration, object is accelerate this way, 14.1 meter per second square to the east. Now we're going to do the other problem. The kinetic friction is the ratio of friction and the normal force. Now we're going to do the cross multiplication. So friction is normal mu sub k, which is the coefficient of the kinetic coefficient of kinetic friction times F sub x times normal force. So this 0.55 is the kinetic coefficient of kinetic friction. As we said, that mu s is always greater than mu k. So mu s is 0.6 and mu k is 0.5. So if we do multiplication, this is 49 Newton, then F 95 Newton. Now the net force at the x direction is 100 minus 26.95, 73.05. Now the net force is this direction, 73.05 Newton at this. Now acceleration is 73.05 divided by 5, 14.61 meter per second square, which is also at west. 14.61 meter per second square